Okay, Assalamualaikum and a very good morning. So today I'll be sharing brief overview of the future trend of antenna system and design. So I'll be using the slides provided by Prof. Dr. Muhammad Kamal Ibrahim because I found that the information provided from the slides is quite comprehensive and suitable enough for you to have an insight and overview of the future trend in antenna design and system. All right, so this is how basically the future antenna may look like, in which the end user may require higher data rate, higher connectivity, seamless connectivity, and multiple devices can be connected with higher speeds at the same time. So instead of using more and more antennas at the same time, so we can just use a massive antenna. Okay, for example here, massive antenna, usually an antenna array, so that the antenna can be steered or beamed towards the intended direction and can cover multiple applications at the same time. Right, so an example of the current and future antenna system needed is the MIMO system. Or massive MIMO, in which it requires multiple input and multiple output. So you have multiple input at the end and multiple output, in which the antenna can be used for various applications, better or higher coverage within the maybe the urban area. So multiple buildings can be covered at the same time, and also it can be directed in suburban area towards the intended houses. Alright, so smart antenna system is basically a combination with signal processing algorithm, okay, that track the location of mobile client device using technique such as the direction of arrival. So in this case, you have the array antenna. Usually an antenna array will be used. So I don't know why I can't write directly here. So I can just put okay, for example, if you have an array, so this is antenna array, and then it will be connected to DOA. So I can't write directly in here, so DOE will be here, and then you have the algorithm, the processing algorithm, okay, that will be combined with the array. So here is the algorithm, or it is called adaptive algorithm, and within this area, oops, okay, so within this area is the signal processing. Okay, so here is the, oops, it's quite difficult to write in there. Okay, so here is the algorithm. Okay, and here is the DOA. I don't know why I'm having difficulty to write on the slide, so perhaps you can see. Okay, so here in the middle is the DOA, the direction of arrival, in which the antenna will be steered or beamed towards the intended direction based on the algorithm. Okay, the algorithm used in here. So algorithm set in here so that the DOA will direct the array, the antenna, towards the intended direction. Alright, so types of smart antenna. So switch beam smart antenna, in which the beam the antenna is designed so that they can have several fixed beam pattern, right? Several fixed beam pattern. So this one will be set to cover the respective users, okay, the end users. So the direction will be set, okay, maybe one to this direction, the other one to this direction. And another one is the adaptive array, which it continually steered to any direction. So it's automated beam steering, so in which it can cover maximum signal to be receiving by more users at the same time. Okay, so it can also null the interference, so better quality signal will be received by the user. Okay, next is the beamforming network. So as mentioned earlier, it's part of the adaptive, so that the antenna can be steered or can be tailored towards the intended direction. Okay, for example, the desired user, you have it here and you have it there. So the from one antenna, the antenna can be beamed or can be steered towards the intended direction. So more users can be more users or more devices can be catered at the same time. All right, so same as earlier. So this is the schematic diagram, how the array antenna will be connected to the processor and to the output and also to the end user. All right, so another method is by using the reconfigurable antenna, so which the antenna can be reconfigured based on the frequency, radiation pattern, polarization, and hybrid reconfigurability. Hybrid meaning that it can be used to control the frequency, pattern, and polarization at the same time. All right, so from one antenna, it can be used for multiple purposes at the same time. So these are the brief description on the reconfigurable antenna design and the characteristics, so you can have a read through of the statement. Okay, another one for reconfigurable antenna, and this is an example of the application of reconfigurable antenna, in which earlier if we just use mobile phone, then we can just use specified lane. However, nowadays we can just enter at any point so that you can automatically be directed or be connected to the required frequency band. Okay, this is how the spectrum allocation in Malaysia. So for different application or different niche area, so different frequency bands are allocated to them. Alright, this is the example of reconfigurable antenna structure. So it depends on the so each design, each shape, and the position of the diode. For example, the switch, usually the pin diode, or a reed switch or ideal switch can be used to tune the antenna to the intended frequency bands. Okay, to address or to achieve the required pattern, polarization, direction, and etc. Okay, another one is the phase array antenna, more or less the same as the reconfigurable antenna, but it controls the phase of the beam or the pattern. All right, so again, you can just read through on the description. And this is how the phase array antenna looks like. So the configuration in which it controls the phase of the pattern instead of the frequency. Okay, earlier one, the frequency reconfigurable antenna only control the frequency. Okay, for example, the antenna may be tuned to 3 or more frequencies by changing the position of the switch, or by tuning to the or activating the suitable switch so that certain frequency band can be achieved. Right, so the massive antenna system that currently used and more development will be done in the future is multiple input and multiple output. in which is a method of multiplying the capacity of radio link using multiple transmission and receiving antennas to exploit multipath propagation. So with, for example, in the urban area, so the MIMO antenna will be placed at the tower, okay, telecommunication tower, so that higher radius, okay, better coverage can be achieved by using MIMO antenna. Alright, so in modern usage, the MIMO antenna refers to practical technique for sending and receiving more than one data simultaneously over the same radio channel by exploiting multipath propagation. Okay, this is how the block diagram of MIMO channel looks like, in which the multiple input signal and then will be processed at the transmitter, and then it will be sent wirelessly towards the receiver end, and the conversion process again happening in the receiver. So the algorithm will ensure that the there's no interference between the multiple inputs send or propagate from the transmitter, and the output received by the end user is expected to be as similar as the input signal, minimal or no interference, and then with higher speed as well. Okay, this is how the sum of the MIMO antenna looks like. Okay, so to cater larger bandwidth, larger area, so more elements will be included in the antenna structure. Okay, so with that, thank you.